All right, in this lesson, we're going to look at how we find angles using sine, cosine, and tangent. Again, we're going to have to be able to identify the trigonometric functions for given angles or angles that we're looking for. And then we need to be able to solve for an unknown angle using the inverse trigonometric function. So first of all, a quick calculator check. I know that we did this in our last lesson, so if you're good with this, that's great. You don't have to, if you're good with it, you don't necessarily have to do this part. You can just kind of fast forward through it if you want. So I just want to do a double check. Again, before we're going to do any calculations, we're going to make sure our calculator is in degree modes. So for most calculators, a lot of calculators, there'll be a little something up at the top. This calculator gives you a little D at the top of the calculator. If it's not in degree mode, see if you can figure out how to switch it into degree mode or stop it and check with me. If your calculator is not in degree mode, you're not going to get the same values as I will. So we're looking for the sine of what angle happens to be equal to 0.3152. So what this means is there's going to be two sides in a triangle, the opposite side and the hypotenuse of a particular triangle make a ratio that's equal to 0.3152. What angle would have to be in that triangle? What's one of the angles in order to make that relationship true? So what we use is we use the inverse sine function. So the inverse sine function on most calculators will look like sine minus 1. So this little minus 1 is another way of writing inverse. We'll look a little bit later at how we put inverse into our calculator. That's a really good thing to know, especially when you come into electrical next semester. So inverse sine, and we're going to take the inverse sine of the ratio, so of the decimal number, and this is one of the reasons why we like to keep extra decimals, 3152 equals, and this is going to give us our angle. Okay, so if you put that into your calculator, you should get, your calculator should tell you 18, and since we're in degree mode, that's going to be 18 degrees. So just do a quick check, make sure you're good with all of them. Cosine, whoops, let me erase here. So inverse cosine of 0.7541 will give you an angle equal to 41 degrees. And then the inverse tan of 2.25 will give us an angle equal to 68 degrees. Okay. So there's lots of really good videos on sine, cosine, and tangent. If for some reason the way I'm explaining it isn't clicking in for you, it's a little bit tricky, please don't hesitate to look up some other examples. There's lots of them if you just pop SOHCAHTOA into YouTube. One of the things I do want to take 2 seconds and talk about is why am I keeping 4 decimal places? So let's take this one, for example. So we could say, we could take this 0.7541 and we could round it. And let's say we round 0.7541 to 0.8. Okay, you don't want to keep extra decimals, so you're just going to go to 0.8. If the cosine of an angle is equal to 0.8, let's see how much difference we get in the number of degrees. So our angle is equal to cos minus 1, or the inverse cosine of 0.8. And I haven't put this in my calculator yet, so bear with me for a second. And we get 36.9 or 37 degrees. You'll notice just by rounding, if we compare these two, rounding makes a difference. So the rounding means we're out by 4 degrees. If you were a surveyor, being out by 4 degrees would make a really big difference, especially over a long distance. So you want to kind of watch for that. If you're also lining up some really precise machinery, 4 degrees could make a difference, especially as you put it out over longer distances. So keep an eye out for that. Always when you're looking for angles, we're going to keep try keep 4 decimal places is a really good rule of thumb to keep. If you keep less than 4 decimal places, any less than 3, and you're going to lose a lot of precision. Keep at least 3, ideally 4 decimal places, unless, of course, it's a number that's just 2.5, 2.5. Doesn't matter if you put the extra zeros in. In this case, you're still going to have 2.5. But try to keep those extra decimals. So that can make just some rounding issues if you were checking some answers, especially answers in SAM. All right. So example 1, what is the measure of angle x in degrees? So the first thing we need to do is we need to label our sides. So we have x over here. So this means this one is opposite. And my right angle's here. Across from that is the 10. So 10 is my hypotenuse. That means this side must be the adjacent side relative to angle x. If we were talking about this angle up here, that would all change for us. So relative to angle x, 10 is h, 6 is o, and along the bottom is the adjacent side. So let's write SOHCAHTOA at the top. Now this is a really great thing, just writing it down just to remind you, especially if you're not sure which ratio to use off the top of your head. Some people will be really good at just memorizing which ratios are which, but I find it helps to have SOHCAHTOA written down. It keeps your orders correct, especially if you're like me. So we have hypotenuse and we have opposite, and we're looking for an angle. Opposite and hypotenuse belong with sine. So the sine of an angle is equal to opposite divided by the hypotenuse. So the sine of some angle, angle x in this case, I've written it as a theta. You can switch and write it as an x if you would prefer, is opposite, which is 6 over 10, which is equal to 0.6. Now we have to get the angle. So our angle is equal to the inverse sine of our ratio, which is 0.6. Plugging that in your calculator, because I like to define numbers, I'll say x equals theta just to keep that simple for us. If we plug that into our calculator, we get the angle is equal to 37 degrees. Okay, so angle x is 37 degrees. Oftentimes for degrees, we'll round to a whole number. Sometimes we'll keep a decimal place or two, but most of the time, just for the purposes of being able to work with numbers, keep with whole numbers. It's going to depend on your trade application, whether you need to worry about more than that. Example 2, what's the measure of angle x in degrees? So we're going to just go through 3 examples of these, and I guess technically 4 examples. So here's our angle x down at the bottom. So let's label our sides relative to x. Well, 8 is next to x, so this must be the adjacent side. 4 is across from x, so it's the opposite. There's my right angle, so this one would be my hypotenuse. Now, if I want to find out what the angle is, well, which ratio uses opposite and adjacent? Sine and cosine both require the hypotenuse. So it's a case of tangent. So the tangent of an angle is equal to opposite over adjacent. So plugging in our numbers. I'll call it x this time, just for the sake of continuity. So the tangent of angle x is equal to 4 over 8. 4 over 8 is 0.5. Nice thing about simple numbers is you get to do a little bit of it in your head. So now that we know that, we can find out what x is. So x is equal to the inverse tan of 0.5, which is equal to 27 degrees. I usually find these ones, people find them easier. They go through them much faster than the first ones. And I think it's because you know how to do your sides already. And a third example. What is the measure of angle x again? So once again, we're going to label it. Right angle, that means 10 is, oops, I just went to right opposite. 10 is opposite the right angle, but it's the hypotenuse. So we'll label that. So 10 is my hypotenuse. 5 is next to angle X, so that means it's my adjacent, so this side is the opposite. So again, just labeling the triangle. Which ratio uses hypotenuse and adjacent? Well, it's got to be sine or cosine. Cosine has adjacent in it. So that's the ratio we're going to use. So the C is our angle. We have the adjacent, we have hypotenuse. You always have to have two of the items that are in, the SO, the color, the TOA. So plugging all of that in, cosine of our angle is equal to adjacent, or A over hypotenuse. So now we put our numbers in. So the cosine of X is equal to 5 over 10, which again, beautiful 0.5. The next one will make you have to keep some extra decimals. Figured we'd make numbers simple to start. So in this case, X is equal to the inverse cosine, because we're looking for the angle, of 0.5, which will give us, inverse cosine of 0.5 gives us 60 degrees. All right, so if you're looking for an angle, we're always going to be using the inverse cosine because we don't know what's next to regular cosine, for lack of a better word. If you're looking for a side, you're just going to use regular cosine. All right, fourth example. Identify the measure of angle A and B and the missing side. So this one gives us, I guess, three things to do. We have a missing side. I'm going to call the missing side X. We'll throw that in there. And I want to know, well, what is this angle and what is that angle? So we've got two angles to look at. It doesn't matter what order we do them in. You'll notice for this particular triangle, we already know two sides. So if you know two sides and it's a right triangle, we can use Pythagorean theorem to find out the third side. So that might be a good place to start. So let's find the missing side first. So when you know two, you're going to use Pythagoras. If you only know one, then you'd have to know what your angle was, and you could solve that way. All right, so Pythagorean theorem says, well, what's the hypotenuse? There's my hypotenuse. So these are my A's and my B's. So 5.4 squared plus x squared equals 12.4 squared. Do some simple evaluation. Now, I'll often move the 5.4 squared as a separate unit. You can evaluate it first if you want. So x squared equals 12.4, so our hypotenuse squared minus the side squared. And that makes it easy to put into our calculator. I'm hoping I don't run out of space here. And now that we have that, we're going to evaluate, and we get 124.6. And then we're going to take our square root, which is 11.2. Okay, so now we have our missing side. So now let's figure out, well, what's angle A? So angle A, well, we need to label our sides. Now, as a rule of thumb, use the sides that you were given in the question as opposed to something you've calculated, just in case you made a mistake. I mean, sometimes it happens. We make mistakes. I'm sure you've caught me making an error on a SAM quiz. It's a matter of an error in a click or the computer system not reading a formula correctly. So you guys have been patient with me on those things, but usually I'll recommend use as many numbers as you can that you haven't calculated. It eliminates error. So we have angle A here. 5.4 and 12.4 we haven't calculated, so let's use those numbers. It's possible you screwed up Pythagorean theorem and you don't want to lose a whole question. So 5.4 is opposite of angle A. So we're going to label it as opposite. Maybe I should have changed my pen color. Which ratio uses hypotenuse and opposite? Well, that ratio is sine. So the sine of angle A is equal to, opposite goes on the top, 5.4 over 12.4, which is equal to, which is equal to 0.4355. So this is one of those cases where we keep the extra decimals. Then we're going to figure out, well, what is A? So A is equal to the inverse sine of 0.4355, which is 26 degrees. So this angle is 26 degrees. Now there's something that I think I told you. If I didn't, I'm going to tell you now. All of the angles in a triangle add up to 180 degrees. We'll put that up here just in case you're reading. So the sum of angles in a triangle equals 180 degrees, always. So if we know this one's 26 and we know that this one's 90, to get angle B, we can just go, well, 180 is all of them together minus the ones that we know, so minus 26 and minus 90 gives us B is equal to 64 degrees. Now you could have also calculated that using another ratio. If we were looking for angle B, what we do is we get rid of this opposite because this side is not opposite for B. This is next to B. So we'd say, well, relative to B, 5.4 is adjacent, and we could use the cosine ratio. So there's two ways you could calculate that, but knowing that all the degrees in a triangle add up to 180 degrees is really convenient. It allows us to solve a triangle. What you've just done here, in math terms, we often call solving the triangle, which means we're finding all the angles and all the sides. So I'll usually give you a practice question or an assignment question that will ask you to solve the triangle. And if it's not specific, solving the triangle means all of the angles and all of the sides, especially if they're not necessarily always labeled A, B, and C. And that finishes off all that you need to know for finding angles. And I'm just going to do a quick lesson on some application of trig functions as well.